Did you do the data tracker upload of the slides? Okay, cool. Thank you.
I think we're good.
Yeah, I think so too.
All right.
Close the webcam.
Okay, this is Quic. If you're not here for Quic, I'd ask you to leave the room immediately. Folks who are standing around and chatting in the back of the room, make your decision now, please. Hi. Please find a seat. As Lars mentioned, we have a packed agenda. So this is the IETF Note Well in its new form.
Even more readable.
Even more readable. If you're not familiar with this, I would encourage you to use your favorite web search engine to look for IETF Note Well. It's the conditions under which we participate regarding intellectual property and regarding privacy and regarding taking photographs, which is a new one, and regarding behavior in general, behavior as an attendee. So please have a look at that if you're not already intimately familiar. We have two sessions in this IETF. Today, we have the hackathon report, an editor's update. The editors, some of you may have noticed the editors were quite busy last week. Then we're going to talk about a proposal for Quic over DTLS and stream zero adjustments from Ecker. Then Martin's going to talk about invariance, and hopefully we're going to get to talking about ECN and perhaps a short couple of very brief presentations about stuff that's being presented elsewhere in the IETF this week. On Thursday, we're going to talk about the SpinBit proposal from Brian, and if we have any time left over, we'll talk about either issues or stuff that spilled out of the agenda today. Do we have any agenda bashing?
Ian.
Yes, Ian.
At what point might the slides that we sent you be put in ever?
They are.
Is that the editors update? Is that
Yeah.
the editors update?
Yes.
Yeah. Okay.
Anything else? Okay. So let's get started. The hackathon. Lars, can you?
Yeah, I don't know if this it seems to work. Right, so sorry?
Lars, I don't know if you have any control over the lighting, but these slides are very hard to read because of the lighting.
Colin, we can't hear you. Can you?
I don't know if you have control over the lighting, but the slides are very hard to see because of the lights.
I
Okay.
can't understand that. Oh, from the light on the front. Yeah, we asked about that. They can't do anything about it, apparently. We can ask the secretariat, but I don't think it's getting fixed in this session unless we want to sit in the dark.
Well, or you can join the Meet Echo and then you get the stream version of the slides. Oh, well.
What?
The left is going off the screen. The projector is widescreen, but the screen is 4:3.
Nice.
Other than that.
Right.
Okay, I'm going to need your help. Oh, crap. Where's my cursor? There it is. So you go, no. Oh, come on.
Yeah, about that packed agenda.
Yeah. There we go.
Right, so
Can you see that?
This is the current version of the interrupt matrix. It's the interactive version. Sorry? Okay. Is this better? Okay, I don't want to. I guess I have to eat it. All right, I can do that. So there's a bunch of implementations of Quic. Some are closed source, some are open source, and this is, I think, the 7th or 8th time we got together to interrupt test them against each other. We typically do an interrupt event before every interim meeting that we're having 3 times a year, and we're doing it during the hackathon before each IETF, which happened on Saturday, Sunday. Basically, if you look at this slide, on the left-hand side, you see the different client implementations talking to the different server implementations. So each client is a row. The greener a cell is and the more yellow it looks, the better. So you're seeing that mostly we have some pretty good interrupt. Well, you don't because there's a twin window in front, but we have some pretty good interrupt on things like version negotiation, the handshake, data exchange, connection close, resumption, zero RTT, and stateless reset. Those are what those letters are for. Some implementations are lagging a little bit behind and haven't really updated to the 4th implementation draft yet. Others maybe only have a client at the moment or only have a server. But by and large, I think this looks very promising. And we are sort of now getting ready, I think, in the interop event that we're going to have in June before our meeting in Chista to finally look into some HTTP, non-HTTP 0.9 interop, but actually using some of the HTTP binding stuff that we've been writing down for a while, but that we haven't been able to test yet because the underlying transport wasn't quite there. So it's certainly still going to be challenging to ship RFCs and implementations by November, but I think it's still very feasible. So the cadence has been good, and I think the activity has been nice. We're probably also going to be doing a virtual interop day again sometime between now and June. Probably going to do a doodle poll either on the Slack or on the mailing list. I would guess that would be maybe roughly middle May or something, sort of between now and Stockholm. And we haven't really discussed this widely amongst the implementers, but my feeling is that for the next virtual interop day and then the Stockholm/Kista interop event, we would do implementation draft 5, which is probably going to be the 11 releases of the drafts that aren't out yet, plus whatever TLS 1.3 is at, which is 26 or probably 27 by then, Ecker. Whatever is the newest and most widely available TLS 1.3. 28, okay. God, we're still almost done with TLS 1.3. Right. So anybody can join, right? So if you have an implementation, I learned yesterday of at least one more implementation that might sort of get ready, done in Rust. And so if you have an implementation and you haven't participated yet, right, please come along. That everybody can invite anybody else to the Slack channel, or you can talk to Mark and me if you don't know anybody. There's public servers, so most of the implementations actually have a server out there that you can talk to in interop tests, and we're using this pretty widely. So if you stand one of those up, people will talk to you or try to talk to you about Quic, and we sort of do debugging on the Slack. Right, that is basically all I had for the hackathon event, unless somebody has something to add. All right. Next on the agenda, we have the editor's update. I don't know who of the editor is presenting that, or all of you. I sense a certain fatigue creeping in here amongst the editors.
Can I get that? Yeah,
I don't know
cool.
what he's doing. Yeah.
Yeah, I was like, I can't remember which one slides come first.
Bear with us. There we go.
Seems to be working. Hot issues. All right, next slide. So the editors went through all the issues. Yes, all of them. At least not, well, it used to be all the issues back until people started creating more of them. We tried to tag, close, or assign almost everything. So quick V2 issues are issues that we don't think are in scope for V1. V2 will happen, and these will ideally be in scope for that. It's always possible that something gets put into V2 now and gets pulled back. There's no rules. It's also possible things get put into V2, and by the time we ship V1, we decide we just don't care. Parked is considered non-blocking, but is something we will re-example before we ship V1. So there are some things that are awaiting more data. Some things are awaiting more implementation experience. Some things are just awaiting someone else to care more than any of the editors do. I think that covers most of them. Needs discussion is, we really want to resolve this soon. So we have slides coming up to hopefully touch on all those. And close is, yes, we either believe it's closed or it's not really an issue or all such. So if you disagree, say so, which some people have. So next slide. So these are items to discuss on the list. We're going to run through them pretty quickly, and unless there's a clarifying question, I think we'd like to punt on actual questions to make sure we get through all of them. So next slide. So fixing HTTP priority for Quic. Currently, the HTTP mapping uses stream IDs, the Quic stream IDs, to be clear. It does not have its own stream IDs. The idea is to add request IDs to the HTTP mapping. And so there would be an ID at the HTTP layer as well as at the Quic layer, and they wouldn't necessarily be linked. The motivation is HTTP2 allows you to have phantom streams in priority, and Quic has no way of creating phantom streams. And so, having request IDs in the HTTP mapping would allow this. So there may be other solutions to this problem, but there is currently a problem with priorities in HTTP, or mapping HTTP2 priorities back to Quic, that there are some features, that this phantom stream in particular, that you can't currently simulate in Quic. So, and yeah, the idea is essentially to propose to extend push ID to all requests. So, next slide. Connection ID privacy. Can we encrypt connection IDs? Yes, but it will hurt a lot. So we've talked about this quite extensively. There are options. They are technically feasible in some circumstances under some assumptions, but they're all pretty horrible in some way, shape, or form, to the extent that it's not clear anyone would be willing to deploy any of them. So we talked about this a fair amount, but sometimes someone comes up with some great idea out of the blue, and so if someone comes up with a new great idea, we should reopen this. But it is currently open, but with needs discussion. So, did you want to add anything, Martin? Okay. Next slide. Priming the client with a connection ID for 0RTT. So currently, when you have a 0RTT resumption token, you basically still generate a random connection ID, whatever you'd like as a client. This would say, when you do 0RTT, come back with this connection ID. One motivation is it makes it easier to limit replay attacks, because if you have various routing infrastructure that kind of maps certain ranges of connection IDs to certain machines, all of the replays would end up hitting a small number of machines. Potentially, it's easier to prevent and detect DDoSes and other similar things. It might also limit some other types of attacks I haven't really thought through. So it's possible to have a new session ticket frame and include a connection ID in it. That seemed to be kind of the most aesthetically pleasing option of all the options. It does require an even wider interface between the TLS library and Quic, which we will discuss later. But it makes it pretty clear that if you come back with the session ticket, this is the connection ID you should use. Yeah. So next slide. QPAC. How far do we want to diverge from HPAC? Mike, do you want to? Okay, I'll just run through this. And do we have a portable mic I can pass to Mike? Because
Just use that one. Yeah.
thank you.
Hi, Alan from Dell. So we now have adopted what was called QCram, and we renamed it to QPAC, if you missed that. It is in its current form, very similar to HPAC. It reuses most of the instructions, and there are a few places where instructions from HPAC can be used in one context, but not in another. So there's a PR up from Mike that redoes all the instructions to be completely different from HPAC, but there's no more places where instructions don't make sense. And it also creates some more small compression efficiencies, but they're pretty minor. So we want to hear from people who have HPAC implementations. If they are going to implement QPAC, do they want to share a lot of code with HPAC, or do they want to start from scratch? Because I think it reduces the shareability if we adopt that PR. So it's kind of pending that. There's also a change in that PR for how strings are encoded, how the static table is referenced. There's some other things like integer encoding. Buck had a proposal about perhaps finding a more efficient way for doing that, and introducing a static table, which is different from HPAC's static table. So all these would take us further away from HPAC, all with some goal in mind. So I think that the question we want to hear from people on the list is, how much do you want to share with HPAC?
Thanks, Alan. Next slide. Homework section. Next slide. So we will be talking about this at a fair amount of detail later on. But to say the least, there are some issues with acts and the handshakes that are some edge cases that are complex and kind of ugly, and in some cases actually can cause some undesirable side effects. I don't really want to go into all of them because I think Ecker's talk will be a better time to go into it, so I'm just going to skip. But to discuss now. Next slide. Great. So this is the one issue I really wanted to talk about because I actually would like an answer from you. And if you don't give me an answer, then I might just basically do whatever the editors and I feel is right. So, now is time to express your opinion. Currently, both padding and ping instigate ACK frames, and they both count towards bytes in flight. So individually, that makes sense, but that has some problems. One is, in the current state of the world, padding and ping are redundant. There is really no reason to use one over the other in the current spec. They are both 1 byte. They both elicit acknowledgements, and they both count towards bytes in flight. The other issue is that there's no way to add padding to ACK-only packets, or to all ACK-only packets. Technically, you could add it to some number, but those would also be immediately acknowledged, and the side effects there are fairly heinous. So for those who want to pad their acknowledgements, I guess in order to provide cover traffic is the correct word, I'm not sure, then they see this as an issue. So it makes it easier to identify potentially what the state on the receiver is from the size of the acknowledgements being sent. But there is a principle here, which is that if it instigates an acknowledgement, it needs to be added to bytes in flight and vice versa. And the problem is, if you add something to bytes in flight and then don't cause it to send an acknowledgement in a relatively timely fashion, you will never remove it from bytes in flight, and then you will get deadlocked, and that will go badly. I mean, it might eventually fix itself, but it's going to take a very long time. So unlinking those two things is very scary, and if someone wants to do that, that's like a research project and a very questionable idea. I have one more slide, Christian, but I will get to you first. Is there a clarifying question about this one? Okay. So therefore, you need an acknowledgement to remove a packet from bytes in flight. Next slide. So option 1, remove ping because it's redundant. But that means you still couldn't add padding to all ACK-only packets. Option 2 is make it so padding does not instigate an acknowledgement and does not count towards bytes in flight. So that means you could send padding only or padding plus ACK. They wouldn't count towards bytes in flight. ACK congestion control, however, is hard, and adding padding to ACKs makes them bigger, and it could potentially make ACK congestion control actually important, opposed to now where we hope it's unimportant. So that would be probably the largest negative. And questions and comments, go for it.
Hello. Yeah, Christian Wittemer. I've been discussing that. I've been surprised. I mean, really surprised when this idea of hacking pad came in. I mean, I'm still not hacking pads in my implementation, but I think this business of congestion control is really a red herring. Congestion control is something which is pretty much selective and selected by the sender. The sender knows what kind of congestion control strategy they apply. They do that in order to make sure that they are sending the right amount of packet and don't suffer. So if a sender's congestion control strategy requires that whatever padding they added be hacked, it's extremely simple for them to, instead of adding 256 pads, to add 1 ping and 255 pads. So the sender, if you have the distinction between ping and pad, the sender that requires congestion control acknowledgement can add a ping. It's an implementation issue, and we could specify that. But at the same time, if you have a pure pad, you can use it in Axe to basically hide your traffic. So I'd like something like option 2 with a caveat that if your congestion control requires that you hack, well, just put a ping.
Okay.
So I think the only observation I want to make on this slide is that if the purpose of the padding, or the sometimes purpose of the padding, is for cover traffic and it does not impact the congestion control, that would seem to be observable based upon the congestion controller's behavior, and you can probably just manage to subtract out the padding without decoding the packets, which makes it not very useful as cover traffic.
Patrick, we can't hear you up here because the speakers all face that way.
Really? Because everyone's really loud when I was sitting over there. Okay, so the observation I said was that if the titular notion of padding is that it's cover traffic, and that if it does not participate in the congestion control, that's probably visible in the congestion control behavior of the sender, and you can do a lot to determine how much is padding and how much is traffic, and therefore its use as cover traffic is probably fairly minor.
One note on that is, I think, and I could be wrong, I think the idea is that when you send an acknowledgement, it would always be a fixed size, like you'd always send 40 bytes of payload, and it would be a mixture of ACK plus padding, and so.
Could you repeat what he said?
I can't hear it, bro.
He said it's the data sending bit that leaks the information.
Jana Iyengar, I just want to repeat for the record that Christian Vietama said congestion control is a red herring. That was a joke, sorry. Completely fell flat. This is a transport area place. This is terrible. Okay, I'm actually now going to respond to something that Christian suggested, which is to add a ping byte. There's a problem in doing that. As a policy, if a receiver of data wants to pad acknowledgement packets always, and also counts it towards congestion control, and therefore adds a ping frame in there as well, if both sides do that as a policy, then you're screwed, because now if you have ACKs going back and forth all the time. It's tricky to get this right. That's sort of the gist of it. If you want to count this towards congestion control, it becomes really hard to get this right.
So I'm going to kind of, in my mind, like restate another way of saying kind of some of the things that Christian was saying and seeing if like that resonates with people, which is by making padding not count towards bytes in flight. That means that padding and ping do become different, and it gives the sender the maximum amount of flexibility in how they want to decide which packets should be acknowledged and which packets should not be acknowledged. So it, in some sense, like gives the sender more options than they have today, which currently their options today they just can't achieve. I don't know.
Mia Kulevin. So even so, I have the dot on my badge. I do agree that padding should probably not be part of congestion control, because you have to take into account that you should probably only use padding when you don't have any other data to send. So your data rate should be really low. Anyway, you don't want to send like a huge amount of padding data. What you probably need is to take the recommendation we usually have for low bandwidth UDP traffic, put a rate limit in there.
Yeah, we could. I would be happy to. It's possible that if we do that, we should do that as an addendum to this, but it's a good suggestion.
Well, let's be clear. I do not propose to not count padding as byte in flight. I do count the padding bytes as bytes in flight. It does not follow that I have to acknowledge each and every packet that has a pad. I mean, in order to meet your requirements, you have to make sure that one ACK arrives from time to time, but it doesn't, like, otherwise, I mean, you could not be on just an ACK only.
Yeah, that makes me pretty uneasy as a recommendation. I'm not saying an implementation can't do it, but
and the other problem is that if you are really concerned that implementations are going to do something crazy in order to screw the other guy, there are 25 different ways of doing that. Okay?
I completely agree.
So we got to cut the line after Jana.
So basically, I would say the flexibility and clear stuff is good. And I have some trust in the implementation. That's all.
Eric Pasquale. So I guess it'd probably be useful to understand what padding is for. So the thing padding is absolutely necessary for is to pad out the CH into the initial packet so it can make 1200. Now, you might also think padding was for making packet size, for evading traffic analysis. And that's what we thought when we did it in TLS 1.3. When we did it in 1.3, the reason we did it that way was because we thought we might need a facility that was a generic facility, but that was under application control. Because the conclusion was it is not possible to generate plausible looking, cover traffic or packet size patterns without the application being very involved. And so, and in 1.3, like we had to like only one place to do this, which is basically like all we had was like this. All we had was like the stupid, the padding on the end of this crypto. So I guess the question is, what is padding for here? If it really is for cover traffic, then it's probably better thought of as a favor that the transport is doing to the application. In which case it really ought to be counted as bytes in flight, and it ought to be just like a frame type that basically just sits there and like it's like as if the application would want to. Not every application has to invent their own way of adding a path, right? But this is it's really not a transport issue; it's an application issue at the end of the day. And if we need to have two kinds of padding, one for like the CH and one for the application, that'd be fine. If for some reason it's confusing, though I don't think it probably is. But again, I guess my basic thesis is this is really like another application data message. It's much more like that than it is anything else.
So Martin Thompson, I came to the same sort of conclusion that Patrick did about the size of acknowledgements. The concern with the second one is that we start sending lots of acknowledgements and they're really, really big and they actually congest the network, but we're not accounting for them properly. That's the real risk here. And to Miri's point, I think we can probably avoid that by simply saying that we can just not send them as often. There is potentially value in hiding what acknowledgements you have, or hiding, well, so it's actually more difficult. Hiding what acknowledgements you have is possible potentially from someone doing traffic analysis, but hiding the distinction between an acknowledgement-only packet and a packet that contains real data is extremely difficult because of what Patrick was pointing out with respect to the fact that you can observe the rates of packets that are sent, and the fact that this is the last packet that someone sends in some cases is often quite revealing. There's some patterns where it's potentially plausible that this would work out, but not so much. So the actual value we get from padding is pretty low, and I don't know what to say more than that. And to Wecker's point, acts aren't that interesting because in theory, the person doing traffic analysis has seen the packets that you got and seen the packets that you didn't get and can make some sort of assumptions about what sort of acknowledgements you're generating. So.
Sybil Langer. I tend to agree with Patrick's and Martin's characterization that, like, I think hiding the difference between acts and real data, it seems like, I don't know whether that's that useful, but it seems if the purpose of padding is to hide like real data transfers and introduce shadow traffic, then maybe we can characterize padding as more like meaningful in the context in which it's used. For example, if it's used in an ACK-only packet, it is considered to be like you're trying to hide ACK frames, so it must be treated as if it was not without congestion control. Whereas if you're sending padding-only packets or sending padding inside stream data or data with retransmittable frames, then it must be counted towards congestion control and act as if the same rules that you use for stream data. And if you get an ACK, you should treat the padding as if it was pure ACK data. And so that seems to provide the most value for me.
So you're suggesting like a 2A, which is ACK plus padding does not count towards congestion control, but everything else does?
Right. So treat ACK plus padding as pure ACK.
I'd
So
be fine with
I want to
that.
inject a stupid idea. Have you, so you could include redundant ACK information in ACK-only packets to make them bigger, right? And that would not count towards congestion control, and it would not be padding.
The problem is that the current ACK format does not allow us to include redundant ACK.
Problem.
Well, you could send it multiple copies of the same ACK block.
Yeah.
Jana Iyengar, I think there's actually, I'm coming around to seeing what Christina was trying to point out. I think it seems reasonable to count padding towards bytes in flight, but not require an acknowledgement for them, because a sender that chooses to count, that does count them towards, if the senders all counted towards bytes in flight, a sender that chooses to send ACK plus padding frames can also choose to send an additional packet periodically to evoke an ACK from the peer. That gives it enough information to keep moving the bytes in flight forward. That's generally adequate for a sender that's choosing to do that. What this tells me also is that all we want to do is allow for this flexibility to remain at the sender, not have to specify it ourselves. I don't think that we should, I don't have a strong desire to do this, but it seems to me that padding ought to count towards bytes in flight just because of the nature of what it is. ACK, we choose not to count towards bytes in flight, again, because of the nature of what they are. They don't fundamentally evoke ACKs, and they have a size limit. Padding can be used arbitrarily, and you could have a packet that's 9/10 padding and just 1/10 actual information. So it seems reasonable to count it towards bytes in flight, but to leave it open about, and not to instigate an ACK, and allow for the sender to send periodically a window update or a ping to get an ACK to open up its bytes in flight.
So to be clear, I mean, I'm going to say right now that that is possible, but that's a lot more complex than I would like to recommend for like most users in the recovery
I don't think
document.
we should recommend any behavior, right? I'm just saying that if a sender wants to do this,
Sure.
a sender will have to deal with that complexity.
Yes,
We
I
don't
agree.
have to deal with it in the spec.
Okay, as long as that's my big point is like in the recovery document, I need to write text that I think like the vast majority of the population should be using, and so like we need to make sure.
Yeah, and the vast majority of the population, clearly we can suggest, padding an ACK frame, padding a packet that's ACK only will have complexity in this sort, but we don't deal with that complexity in this document. That's, I think, adequate for us to say. So we don't have to deal with the complexity of what happens if we're padding an ACK packet.
Christian, the mic line was closed. Can you keep it really brief?
Yes, I just want to point out that we have other frames that are not ACT, like the past challenges, for example.
That's ACT.
Okay.
The text said the past challenge is not acknowledged. You are sending a past response instead.
I think we need to move on. We're getting over time.
Okay, thanks. Oh wait, is there one more issue?
Nope, that's the end of the deck.
Did we want to have a hum or something? Like
Sure.
I want to write something up here, and like the current status is like broken.
But
So can you formulate the questions, or do you need
You want me to formulate the questions? We have option 1, we have option 2, and we now have an option 3. And the option 3 is that padding frames count toward bytes in flight, but do not elicit an acknowledgement, which violates the principle that Ian articulated earlier. But we will put a fence around that and say that if you embark into this territory, you're on your own. We're not helping you.
You're engaging in research.
Does that sound like a reasonable formulation for those people who are?
I think those are the 3 options, except I think Subodh also mentioned option 2A or 4, which is 2, but only make it so padding by itself still counts towards bytes in flight. ACK and padding is like special.
So can I
It does
task
not
you
count
guys
towards bytes in flight.
can I task you guys with preparing one slide that we're going to show at a later point that spells out the options, and then we're doing the hum later, rather than doing it on the fly now?
We can do this on Thursday, I think.
Yeah, we'll do it on Thursday afternoon.
Or Thursday, yeah.
But my plea to people involved in this and who have an opinion is to think about this and think which ones you could not possibly live with. And I think that's probably something that we should use to draw the line rather than anything else. I'm not hearing any strong views on things that are completely bad. So if people want to think about that, we can make a decision. Eka.
And now Ecker's going to demonstrate his typography skills to us.
This is the best part.
It makes the content seem so friendly.
It's a cheap knockoff of Comic Sans.
That's because Google's fault, huh? It's what?
It's a cheap knockoff.
Well, I mean, it's come at Google Sense. Right. So I guess, yeah, I sort of dropped the bomb on the list a few weeks ago. I'm going to try to tell the story in what seems like a logical order, which is not the true historical order, but maybe is a more reasonable order for understanding the situation. Next slide. As I said, a logical order. So I was going to talk a little bit about like how things are currently structured and a brief survey of like some of the things that are making us sad about the way things are currently structured. A little bit of root cause analysis, and then a discussion of the sort of crypto stream proposal that a bunch of us sort of worked on for a while. And then finally a discussion of like layering and DTLS. So as I say, this isn't like quite the logical order, but it like helps understand sort of like the state of the option space. Next slide. So like this is my version of like the quick architecture diagram, which may not be anybody else's version, but it's how I think about it like in my implementation. Like at the bottom, they're quick packets. And on top of that, there's like the streams engine whose job it is to like make sure things get delivered. And like on top of that, like sort of jointly sit like the TLS handshake as like a special case application, and then the application, and then the rest of the applications. And so this arrow is supposed to be that like, unfortunately, the TLS handshake has to like talk to like the quick packet engine quite a bit to like tell it things like, you know, you can send data and here are the keys and that kind of crap. So I think like, I mean, that's like the implementations I've seen kind of look like this, although I understand Sabots is like much more cool. Next slide. Unfortunately, so like the thing is that the TLS stream like just uses like the special stream 0. And this is like kind of like turned out to be like a huge hassle that has made a bunch of us super sad. So it's got a bunch of annoying properties, all of which kind of had to do with it being the special snowflake. And I liked Ian's slide. It's like stream 0, it's special. So first of all, it's like, and these are in like no particular order, but I tried to group them. The first slide is supposed to be things about like data, and the second slide is supposed to be things about acts, but like frankly, they're all kind of intertwined. So first of all, sometimes stream 0 is like encrypted and sometimes it's not encrypted. So like everything up to like the NST is encrypted, but then the NST is like, it's not encrypted, and the NST is encrypted. So like A, this is just dumb, and B, like it causes real problems when you want to retransmit, because say like the SFIN gets lost, right? Say you have an implementation which sends SFIN and ST concurrently, which is totally legal. And like the SFIN gets lost, but you've already cut over into like into like writing mode. And so now when you need to retransmit, the SFIN in the clear, but the NST encrypted. So that's kind of a hassle. It's a hassle implementation wise. It's also a hassle because it means like a special like affordance from the TLS stack that like says, listen, these bytes, by the way, are like in the clear, and these bytes are encrypted, which is like not a stack that something the stack normally wants to give you. And you can't see it by inspection, by the way, because at this point we so cleverly hid like the content types that they just like encrypted data. That brings me to the second point, which is like this requires like an incredibly tight amount of coupling with the TLS stack. Where the TLS stack like basically it's like TCP over TLS over TCP is like really straightforward. Like basically you like bring up TLS and like at some point the stack says you're ready to write and you start writing. But that's not true here because the problem is you're also like sending things at the same time. And so you need to know like where's the boundary between the flights, exactly what state is the stack in, depending on whether you're doing HRR, there are multiple round trips. And so like you need to know, for instance, is the first thing that comes out of the server's mouth, is that a server hello or is it an HRR? Or maybe it's a stateful HRR, maybe it's a stateless HRR, and all these things you have to know in order to make sense of the system. Stream 0 is also goofy in that you're like exempt from flow control during the handshake because you want the handshake to finish. But then you're not exempt later, and so now you can like overflow the flow control window. Now you're like in negative territory, which is shitty. This is sort of like a trivial thing, but like nevertheless a piece of annoyance to me. Like TLS 1.3 has its own notion of like when the 0RTT boundary is. When you're like sending like data in TLS 1.0 0RTT, but although we send 0RTT data, we don't send it in TLS13 0RTT, we send it in Quic 0RTT. And so like the TLS stack like sends this max stream data thing, which says how much 0RTT data you can send. But the way it works is it says you can send an infinite amount of 0RTT data, and then there's some other thing where like you tell the Quic stack how much data you can actually send. And oh, by the way, TLS13 also has this thing that says, I'm done sending 0RTT, and like the next thing will be, the next thing will be like handshake packets. You still have to send that because that's the only way to make sense of the things in the TLS layer, but it's like only doing that because we're not sending any 0RTT actually. So that's kind of stupid. Another minor thing, you can't like bundle encrypted and unencrypted data in the same packet, which is really annoying if you want to do like 0RTT because you want to send CH and then whatever was going in like 0RTT. You don't want to do that. You can't. Now the good news is maybe like the saving grace of that, I guess, is maybe you have a really cruddy MTU, so you're like 1200, so that doesn't help that much. You'd also like to bundle fin and other things too. And it's like all this is, and by the way, like not only do you like know a lot about what the TLS stack is doing, you need to like a lot about crypto. Like a pretty substantial fraction, like the TLS record layer is like recapitulated in like the Quic implementation. And like just the other day, like I had to like copy out the HKDF expand function from Mint and put it in Mink so I could like do QHKDF expand. So I mean, again, this isn't like a nightmare, but it's kind of a pain in the ass. Next slide. So the ACK rules are just like baffling. Sometimes you're never supposed to ACK something like you're never supposed to ACK anything at a higher tier of encryption than you currently are. But again, this puts you in a position where you're like trying to send after in the handshake, and like some of these things are clear and some things are encrypted, so it's confusing when you can send what. Christian pointed out this nice attack where because you're sharing sequence number space and ACK space, it's possible to get in a situation where the attacker sends you an unencrypted packet that is in the stream space that the client, if you're a server, that the client would have been sending for a ciphertext. And then you'll ACK that in the unencrypted packet. And at this point, the client thinks you sent it, but you haven't gotten it because you tried to do it unencrypted. So that's a mess. You can also, it's also really easy to have situations happen where you get contradictions between the ACKs and the handshake state. So the easiest version of this, right, is the client sends CH, and the server sends SH, and for some reason, the server does not give you an ACK for the CH. Now, you know for a fact that like that the server got the CH, it wouldn't send you an SH otherwise, but like you're still like retransmitting the CH madly, like until it ACKs it. And this is a real problem with the CFIN, where this actually turns into a real issue. So you can get so you can get in these kind of states. And finally, there's this problem that I think Martin Seaman raised, where the CFIN reliability is a problem because, again, it's because of the various crypto tiers where you're supposed to be ignoring data that's unencrypted, but if the ACK for the CFIN gets lost, then he's retransmitting it to you. You just drop his data on the floor because it's the wrong level of encryption, and now you can't ACK it properly. So again, this is kind of like a pain in the ass. And finally, the next slide is like stream 0 is like in people's code. Like everyone's code is like littered with these special case situations where you have to handle stream 0. Like here's something from Patrick's code from MozQuic, but it's not just like MozQuic. Like when Martin rewrote like the Mink stream handling code, there's like an explicit value in like the connection function called stream 0 that like he's constantly referring to. And then like all the other places where you want to iterate over the streams where it's like, except stream 0, don't iterate that one. Which by the way has been made much worse by Uni and BiDi because like Uni stream 0 is like totally valid. It's like totally valid. Okay. Next slide. So like, we're kind of like I had this slide, which I didn't put in there, which is like the shame spiral of like what happens, which is like, we find some problem and then we're like, oh, we'll just special case this problem. And we'll like make another affordance to like look into the TLS stack. And then you feel shame and then you get over the shame. And then like when the next thing happens. But I mean, the real source of the problem is this. We're trying to set up a reliable transport so that we can like carry TLS, which depends on a reliable transport. But the reliable transport itself partly depends on TLS. And so like these things are interdependent. And so like, as long as that happens, you're constantly gonna have problems. And I think there's general agreement on that point. And now what we do at that like is a different question, but like there's general agreement that interlocking is the source of the problem. So next slide. So I mean, so the general structure to break this dependency cycle is to somehow separate the transport the crypto is using enough from the transport the application is using that the crypto transport can function properly even while the application transport isn't completely spun up. And like this question mark is precisely the source of the problem that we now have. But like, hopefully if we do those things, we'd have profit. Next slide. So this is the part where I'm like telling the story in like the natural order rather than the true order, which is like that I like said like, well, why don't we do some really radical thing? And then a bunch of us, with Ian, I think being the instigator of this, but a bunch of us sat down and tried to like think about what's like a less radical thing that would work. There's been a bunch of discussions of this sort of general idea, which I think, am I allowed to say like what we ended up calling this, or are we not going to call it that? We're not going to call it that. Okay.
No,
okay.
do it.
Well, okay. So the idea goes under the name of like crypto streams and crypto acts, which, as you can imagine, immediately became cream and cracks. So we probably won't be calling it that if we do it. Oh God. Yeah, that's great. Thank you. So the general idea is like pretty straightforward, which is that you stop having, like, you get rid of stream zero becomes a regular stream, and you have like essentially you replicate the stream zero frames into like crypto streams frames that have like a different frame ID, and they probably don't have a stream ID in them, but otherwise they're basically the same. And you replicate the ACK frames into crypto ACK frames, and then basically, as you can see from this diagram, like everything that goes in like the TLS handshake like uses that crap, and everything that goes in the application handshake uses other stream stuff, even though they're otherwise basically identical. And so this lets you separate out, at least in theory, the data and also the ACKs. You still need this goofy this goofy arrow on the side. And one of the things I think we had not consensus about, but has been also been floated, is separating out the crypto, actually having two crypto streams, and I guess maybe two crypto acts, I'm not sure, because of the post handshake data, which has to be sent encrypted. And so you don't have to know where the boundary is, but you could either have one crypto stream and cut it over, or you could have two crypto streams, and that made the boundary clearer. So that was also floated.
A clarifying question: if you were going to say in the mailing list, you were going to send a PR, and how this would work if we stayed within the current framework, is this your idea here on slide 9 of what that PR would be represented as visually?
Well, I mean, it would be ASCII art, obviously. Yeah, I think what I would say is that this design, plus a couple other things we floated, is probably the strongest design we have for staying roughly within the current structure, but trying to address as many of the problems as we can.
Oh, okay, then I think maybe we want to make a larger distinction between the kinds of streams that you're going to use to create crypto, because what you're fundamentally doing is saying that the crypto stream is a special case of a reliable stream, which is now part of Quic. And there may be other uses for that underlying reliable stream that want to behave this way, even though there are other ways of creating reliability in the regular stream.
I'm going to need you to scroll back 30 seconds and say that again, Ted. I'm sorry.
So I think what you've done is to say that these crypto streams have a fundamental property of reliability, which was the problem you had before, bootstrapping a TLS on top of something that's unreliable. And I think that fundamental property of reliability has applications outside of the one you're using it for, and we might want to generalize it so that you can use this form of reliable stream in certain other cases.
Okay, so I think
everybody else hates this idea, but I thought
right. Well, I guess so. What I would say about that is
at least everybody in the front row.
I guess what I would say about that is that it's true they have the fundamental property of reliability, but the other property they have is exemptions from a whole bunch of other rules that Quic actually imposes on the streams otherwise, and so it's dangerous so applications should not be using them, I guess is what I'd say. And they
So
exempt from flow control.
If you're going to tie the fundamental property of old style TCP reliability to always unencrypted, then I agree with you. You never want to use them for anything else. But I think that you're creating a different marriage of convenience that is not required by the fundamental underlying problem that you're trying to solve.
It seems like we're moving on to discussion. Jonna, is your question clarifying?
No, it is.
That means no, by the way, just so you know.
Scouts honor, it is. I think it's worth clarifying that I think of it as crypto stream frames rather than crypto streams. I don't know if that's what you meant to say or if you were deliberate in saying crypto streams.
I'm not sure I appreciate the difference.
The difference being that people then it's basically this isn't just. I want to avoid the question of is this just stream 0 again, because it's not a crypto stream we are talking about really. That's an implementation question of how exactly you deal with those frames that are arriving.
Well, I think the relevant point is that what makes them different. I guess the relevant point from my perspective that makes them stream-like is that someone's responsible for assembling the frames back into a coherent-looking sequence of data.
Yeah, that's fair.
So that was a clarifying proposal, not question.
Okay.
Okay. Thank you.
Next slide. So, like as I sort of said, this is probably like the minimal change that does much of anything at all. So I think it solves the following problems, I think, reasonably well. It solves the flow control problem because you just like exempt the thing from stream 0 and you don't have to like process to process it. It provides some cost clarity about what's encrypted and what's not. The cost of that, as I said, is like even more invasive, like widening of the TLS interface. It solves the whole sort of unencrypted packets because you would just basically say if you ever receive a crypto stream ACK, if you ever receive a crypto stream ACK for a packet that was sent not in the crypto stream, you freak out. And so that'll cause connection termination as opposed to holes, but we already know how to terminate the connection as a man on the side. And it makes the ACK rules more straightforward again, because basically things that come in the crypto stream, you act the crypto ACK, and things that came in the regular stream, you act the regular ACK. So each tag, right? And this has some similarities, obviously, with like the DTLS epoch ACKs, which kind of have the same property. There's other problems, like I had a long list to solve some of them, as I said. I think there's some discussion of a solution for the CFIN reliability problem that was called handshake done. The reason I have it like instead of second bucket is because it's like a different situation, and B, I don't like it as much. So there's other problems, I guess, we could either try to solve, or we could live with them. I guess one thing I should say before I like show my next couple slides is like, I am not in any way saying one could not build a version of Quic without like doing any of this crap. Like, obviously you could, we have like working implementations. We can just keep banging on it long enough, like we can make it work, right? What I'm saying is that we're doing a bunch of annoying special casing, this sort of shame spiral I was talking about, and it'd be nice to get out of that shame spiral before before we ship the product. Not that this is like, none of these things are like deal breaking things that we cannot possibly ship a protocol without fixing. So my argument isn't that. So if people think it is, then I retract that. Next slide. So this is like the slide you saw before, but like all it has is like a big box around like the new things, right? And so I guess it came to me at 4 in the morning as I was thinking how to talk about this, that this morning, by the way, so like that's why I'm probably more disjointed than usual, is like, how do we get into this state? And the way you get into this state is, and so the problem is, like I said at the very beginning, we have like the transport, and we have the transport trying to set up the crypto, and we have the crypto itself, right? And in order to make that work properly, the crypto transport needs a lot of knowledge about what the crypto is doing. And so they have to like really have this bear hug. And so like, basically that's why I put it in the box like this. And so basically what this crypto stream crypto ACK thing does is basically like rip out the parts of take the parts of Quic that like were responsible for doing the minimal transport you needed, and like clone them over and bear hug them to TLS. And I really should have made like this diagram, like this middle line here. Do I have a marker? No, I don't. No, it's fine. Here you go. Yeah, take that line that's under TLS handshake and make a super pet. Or maybe super dotted, I guess, is really what you want. Because like that's a really porous boundary, because you're constantly having to tell those things about each other, right? And so this is what you have to do to make this not suck. So somewhere this has to be a super wide boundary. So like the other way to make a super wide boundary, so one way to make a wide boundary is like clone off like the Quic parts and like make that boundary porous. The other part of the other way to do it, next slide, is to like,
oh shit.
Is to like isolate all that crap into its own thing, hence like DTLS, right? So like the blue parts obviously are things that are new. Very good, Mark. Very good. I'll just assume there's consensus and we'll move on.
Some people took some of your time, so please take a bit more.
Yeah. I floated this in a list, so I don't think explaining what I'm suggesting is particularly difficult. What I'm suggesting is take the parts of Quic that involve crypto, throw them away, and like run the parts of Quic that involve transport and run over DTLS. And that's like basically what I'm proposing. So in this slide at least. And so the primary signal you need now is this arrow ready that says like you can now write data. That's basically the major signal you need. Next slide. So I mean, this is like obviously like a much bigger change. The good news is it's like mostly deletions. I like went through and it's like involves like ripping, like deleting a bunch of code, like pretty much all Quic TLS and modest chunks of Quic transport. It does revert some of the decisions we made earlier, and Ian pointed out to me that we previously talked about having crypto at least somewhat subject to flow control, and now of course we totally unsubject to flow control. That's not really a big deal. You're not going to send very much data anyway, but it's a decision. You would need some small changes to details 1.3, which I can talk about a little bit. I think the primary issue here is we spend a lot of time hacking on the Quic packet structures, and in some ways they're better than the DTLS packet structures, in some ways they're worse. And there's a more advanced connection ID structure, though, which actually kind of got borrowed from DTLS's connection IDs. So basically, like, we would have to figure out how to deal with that problem by probably graphing that crap into DTLS, which mostly is a matter of copying and pasting. The good news is, like, essentially every problem on the first 3 slides, like this addresses. It may create some new problems we don't know about, but it addresses all those problems. Next slide. Oh, I wish I. This is what I meant to show, but it's roughly the same anyway. So that's the good news. And it says SIP, which I don't understand. I told you it's 4 a.m. And the other thing I should mention is we now have like several partial implementations of this, and the cases I'm aware of, and every case is involved like deleting a crap ton of code. Though I think in fairness, one could say some of that code already was in the DTLS stack, so it's not like it's not like the code just went away, but it like went somewhere else. And I think on average it probably went away too. Next slide.
Where's the other blue sheet?
Somebody else brought it up here. I think isn't it lying there?
That's the first one. There's another one.
We had 2 people come up. Anyway.
Did we?
Keep going.
So this slide might be called like things that are like make people less happy. So obviously like DTLS would become the Quic wire image. We have a lot of flexibility in that because I sort of stuck my foot in the door of DTLS right before I went out the door. So right before they closed it. So ultimately I think we could graft essentially all the Quic wire formats onto DTLS if we so wished. Probably not exactly, but like if we get very, very close. There's if you don't do that, there's maybe a small amount of packet expansion. If you do that, there's none. Making I said the interface between DTLS and Quic was very thin. It's not quite. There's one more thing besides the arrows, which is you need to have access to the DTLS packet numbers because you want to use them in the ACKs. And so that requires basically being able to ask the question, what's the next packet you're going to send out, and what was the sequence number of the packet that just came in. That's like very trivial. It requires very little changes. And of course, you also need to screw with the ACKs a little bit to carry the DTLS epoch separately in the ACK. That's actually not so different from having the separate ACK frames that you had to do to make crypto ACK work. And I think the other thing that like obviously is true, so I should just say it, is like the DTLS spec and like the implementations are like less mature than the TLS 7.3 spec and implementations, right? So that's certainly true. Next slide. Right. So I think so 2 things. First of all, you can't, if people talk about what I want to talk about, speakers talk about they want to talk about. But what I like to talk about is like not layering, but architecture and like what's the right architecture going forward, and like how do we make that decision? How do you think about that decision properly in a sensible way? So if people think this is like totally wrong architecture, I'm like totally like I'm like happy to hear that from them, right? I think I've tried to make the best case I can for like for the various options we have, or at least the most accurate case I can. So I guess, but also I think like the optics of me sort of standing up here pitching like one thing like kind of shitty. So Ian did a really good job, I think, of helping us build a consensus on some other options. So I was hoping Ian would come up and like we could stand here together and like talk about the options like rational people. And like worst case, I'll like clock him and then we'll do what I want.
You're really you're telegraphing your strategy here.
No, I just think
you guys gonna hack.
Yeah, so I wanted to give my take. I've talked with Ecker quite about this proposal over time, and I think my take is, number one, I think you pointed out some issues that when I went back and looked at our code were definitely issues that like could be improved upon, like having the unencrypted or stream 0 be half unencrypted and half encrypted is totally annoying, and the flow control change is totally annoying. And some of the issues that were pointed out are just new issues that I hadn't really fully considered the complexity of. So I do think that we really should like do something, and I think that the status quo is, as Zachary said, like workable, but like probably not optimal. And I think we can do better. So you know, on a personal level, I'm not like at all up for swallowing the entire like, you know, DTLS proposal all at once, as I said in the list. But I think something like of the form of the like crypto stream frame, crypto act frame, pretty much solves all the issues that are outstanding and is a pretty plausible, at least, concept. I will say that based on my experience with the Quic working group, I think almost anything we do, there's certainly the larger change we make, the more the Quic working group will just beat it back into the shape of whatever the Quic working group seems to want. I don't know, but we seem to evolve. So like one slide was like, oh, we could just stick DTLS here on top of the crypto or the Quic framing layer. Yeah. And I was like, well, all the Quic working group is going to do is beat DTLS into the exact shape of like whatever the crypto stream frame plus like crypto ACK was or something, right? I mean, so I do think that there's a certain sense in which, you know, perturbing the system a lot will actually just end up being a lot more changes in the long run because we'll perturb it a lot and like move back. I don't know. That's my take on like how the group has tended to work. So I'm not a big fan of like massive perturbations, but I do think we need to do some work here. And I also don't actually think we're going to solve this today.
Right.
Because I think these problems are hard.
To the working group feedback and guys on the microphone also be brief because I expect the lines to grow.
Can I say one thing, Loris, before we do that?
Quickly.
Yeah. I mean, so like the one thing I've heard to say as you're doing this is like, one way to think about like actually this sort of earlier diagram with crypto streams is we're like replicating the DTLS reliability machinery, like we're replicating the DTLS reliability machinery over TLS, right? And so like that's like the opposite of what you just said.
Right. Whereas I was thinking of it as I already have these reliable streams, and so I'm going to reuse the code I have instead of like implementing DTLS as well, right? So I mean, part of the perspective is like if you only have Quic, then like bringing in DTLS is actually bringing in a net amount of code and adding like more complexity. But if you already have DTLS, then maybe it seems simpler to do the opposite. So.
Okay, so we have a half an hour to discuss this. I think that's enough time, but please keep it brief.
Philhan Baker, I like this architecture. I think it is the right architecture for my problem. My problem may not be Quic though, in that my interest is web services, and Quic seems to me to be very much aimed at HTTP type things. And it may be that we could apply this approach to the web services problem, see what it looks like there, and then see if it makes sense to apply what is learned from there onto Quic. In that at the moment, when I look at Quic and look at running web services over it, it is really a high barrier to entrance right now. It's difficult to understand what the drafts are doing or how I would implement it. The DTLS approach looks a lot cleaner to me.
Hi, Brian Trammell. So I was, before I saw these slides, I had a kind of this, Stream 0 is kind of icky feeling. Stream 0 is really, really, really icky, right? It's bad. So we have to do something, and it's going to look something like this. Like, so I think this, when we started Quic in the IETF, we had this idea that we were going to have sort of this C-shaped architecture where there's Quic above, Quic below, they're connected to each other, and there's TLS in the middle. That was kind of the researchiest idea we had, and I think what we're finding is that's not working. So we need an architecture where we essentially do have, we explicitly acknowledge that we've got two different transports running, right? Whether one of them looks more like Quic or is DTLS is, I think, an orthogonal question. I'll point out that if we're going to go with this, it's probably a little strange to have the only non-encrypted streams in ACKS be called the crypto streams in ACKS, but that's you know, maybe not. One question, huh?
Hands crack.
Hands crack, yeah. One question I would have with respect to, I also think that, like, so in general, I think the idea that DTLS is the encrypted wire image for future transports encapsulated over UDP also makes a lot of sense to me. if there's not a lot of appetite for jumping into that right now, is there a way to make sure we can get there, right? Like, so if we do this TLS handshake, crypto stream, crypto act thing on top of Quic packets, is there a way that we can make the version negotiation with respect to this work so that we could move over to a completely DTLS wire image in the future?
The DTLS type bytes are, I mean, we'd have to work that out. Basically.
Yeah, okay.
I mean,
then the other question, another question is, does this make coexistence with Gquic easier or harder?
I think
you don't have to answer that right now.
Yeah, I don't know. I haven't actually thought through that part.
Yeah, but that should be so. So there's 2 wire images on the table right now. We might be putting 3 wire images on the table. We need to make sure that we can move among them, I think. So, and that's a longer discussion, and there's a lot of people online, so we'll continue on the list. Thanks.
Mike Bishop, Akamai. So I wanted to comment, this is way too low. Okay. So we, part of our goals for version negotiation were that we would be able to flexibly move between lots of choices that we might make in the future that we don't know now we want to diverge from our current plans. And one of those is that a version implies your crypto protocol. And we've agreed that for version 1, it's TLS 1.3 or its possible successors. If we change the wire format to be DTLS, we have committed all future versions of Quic to using DTLS or something that pretends to be DTLS. And I think that would be a pity.
So I think that's sort of true. I mean, that's true in some sort of trivial sense, but let me push back on no, sorry, that was too, I didn't mean it that way. We've committed basically, at present, we've basically committed that like all future things have to look like the current Quic framing, because or what their variants which are very, very narrow, right? Mm-hmm. And so I think you would do the same, because you would do the same thing with DTLS, namely you just take what the DTLS invariants are, which are not too dissimilar from the Quic invariants, and call those the invariants instead. And you would clearly encrypt the initial handshake packets, so you protect those as well. So I think you would, yes, it would be true that you'd be impersonating that invariant, but and you can call that impersonating DTLS, but it's sort of not exactly.
I have a detailed question.
Yeah.
One of the nice perks of the
microphone.
Thank you. One of the nice perks of the Quic version is it's like very close to the front of the packet. My understanding is that DTLS doesn't have that property.
Well, okay, so let's take a step back
So
here.
in like 5 bytes, I can determine like
Quic version. Okay, so the Quic short version, of course, has no header, has no version at all.
Right.
This thing I guess I wish I'd gone into in the spirit of full disclosure. That currently the DTLS initial negotiation is in the clear, not encrypted. The first two frames are in the clear, and so obviously we decided to obfuscate those, and so we need to have an obfuscation format for those, which we just lift essentially directly from Quic, and so that would have the version numbers right there. But that would be a new work. My point is that's new work, so that's why I meant by full disclosure.
One quick observation is that the queue is still growing, right? So,
Yes.
so you got to speed up if you have any chance that anybody is.
We're not draining the queue at the appropriate rate.
To comment on that, Ecker, what I think Ecker was saying is, in some sense, that possibly could allow DTLS to fit in a future version of Quic to encompass DTLS inside of it, because we would essentially still be using the Quic version to do version negotiation, and we could still maybe use that first bit. Maybe, I don't know.
Yeah. In fact, we talked about something like that separately. I think, I think certainly, if to the extent to which which concerns are about the wire image, I think there's a lot of flexibility around wire image if we need to do that. I know the people in the DTLS working group, and I'm pretty sure we can impose whatever wire image we want as long as it's sane on them. But and that may or may not be the issue. I have no idea. But
And then my second observation is that it feels like special casing stream ID equals 0, and special casing stream frame is this type byte or this type byte is semantically equivalent, and really it's the differences between them that solve a lot of those problems. Like stream 0 is only ever sent under handshake keys.
I think at some level it's true, but I think if you look at people's code, it's absolutely full of special casing the stream ID space. So if I had to make one change and one change only, it would be to merely take stream 0 out of the stream ID space. and call it stream 0, because even that, like if I did like only one change, that wouldn't make any of the architectural issues any better. It'd make the code a lot simpler.
We're going to cut the queue soon.
Yeah, there was a +1 from Martin Duke to Mike's second point. And please be concise at the microphone.
Okay, Spencer Dawkins speaking as the responsible lady for Quic. I don't have any questions. I have 4 things I need to say really quickly. They are all 1 sentence long. First, I picked the chairs for this working group for a reason, knowing that there would be days like this. You're welcome. Second, I expect the working group to make an informed decision and recommend doing the right thing. Third, I believe coming off TLS 1.3 is a recharter, because the charter is extremely explicit about that. That's not fatal, but we're not talking about dorking with milestone dates anymore. Number 4, speaking as Spencer now, I follow this working group more closely than I follow any of the other transport working groups. Sorry, other transport chairs. And I don't have a good feeling about version negotiation today, and I don't have a good feeling about the working group member expectations for how often we would roll version numbers. I think I've seen mailing list traffic that went in both directions on that. Like, why not? And we'll be on one for 5 years. And that thread kind of dropped. That's the one thing I'm really curious about on all this. So I'm echoing what Brian said, and now I'll stop talking. But I'm here all week.
Okay. Just to that last point, my impression from talking to folks is the intent is, of most, is that we're not going to wait 20 years or 10 years or even 5 years for Quic V2. I don't think that's controversial.
Don't tell me.
Okay.
I just need to know the answer. You know the Victor's also.
Yes, I got Victor after Christian. That was roughly when he popped up.
Chris Wood, I just wanted to second Spencer's second comment, which is that we definitely need to make an informed decision, I think, and experimentation is definitely a key to that. Like I was saying, that some people already started working on this particular DTLS architecture, and I would like to commit some more time myself to experiment with it and see what is the right approach. Because it's not entirely clear to me just by looking at this particular diagram or the two, what is, the cleaner the designs, but considering that we have a lot of flexibility with DTLS right now to change the wire image if we need to satisfy this particular use case. There's certainly, if people can spare the cycles, an opportunity to get the architecture right, hopefully without affecting the schedule too much. And I don't want to comment on that because that's kind of outside my wheelhouse, but I think this is something we should definitely be pushing for to make sure that the architecture is not, we don't make any shortcuts with respect to the architecture strictly because of scheduling reasons or whatever. Thanks.
Janai Iyengar, I have, I think, 3 points. I'm going to try to be quick. First point is I was thinking about what other, this is the devil we have, the one in this picture. And the next picture is the devil we don't know.
The devil we have. The first picture is the devil we have.
Oh, right, there, fair enough.
Even further.
Even further back, yeah, fair enough. Yes, that's the devil we have. The devil we have and the devil we don't. You know the arguments there, and you already stated that, so thank you for doing. By the way, thank you for doing this whole presentation. This was excellent. I think it was very useful. And the exercise is very useful as well. It just occurred to me that one thing that hadn't showed up anywhere is that packetization, if it's going to sit in DTLS, right now the Quic short header has 3 packet types, and that's based on the size of the packet number. The packet number size uses the BDP, the sender uses the BDP to determine how large a packet number to use. Yes. And so that's another bit of interface that will have to change if we want to retain that efficiency. If we choose to discard it, that's fine. But I'll remind folks that a lot of Quic is about efficiencies, and losing that would not really be valuable. That's point 1.
Yeah, so we spent a bunch of time on the DTLS record format, and I think made some optimizations which may or may not have been the right optimizations. And so I think I think that and frankly, this is an area where I think this working group probably understands the problem better than the DTLS working group. If people thought that that so GTLS has essentially two header formats for the encrypted header, one with a long sequence number and one with a short sequence number, and those are the only things it's got. And the short sequence number is shorter and the long sequence number is longer. And so if people think that's the wrong set of design choices, that's like something which is totally I don't know, maybe we should fix that, right? I mean, and honestly, I guess what I would say is if people think it's the wrong set of design choices, even if they think the rest of this stuff's a terrible idea, please come to TLS and tell us the wrong set of design choices so we fix it, right?
Yeah,
Because we're stuck with that.
I'd be curious to know more about the DDLS design choice for the packet number size, because I'd like to know how it's decided. But that's a separate matter. I'm just trying to point out that there are issues here that occur to me now as I'm sitting here at the desk, and that's basically the first point I wanted to make, is that there are likely issues there. The one difference, though, is that those are probably about efficiency, not about correctness. That may be an important distinction to make. The second point I wanted to make was that you were talking about the shame spiral. The shame spiral starts a little bit further before, and you know this because we were in the same conversations early on about how to replace Quic crypto with TLS or DTLS. And at the time, and I'll remind folks again that Quic crypto is different from both TLS and DTLS in that it was very intertwined with Quic. It was different from TLS in that it wasn't a purely stream-based, it didn't assume a stream-based model. It had this tight connection with Quic in that Quic knew about the packets and Quic crypto knew about it as well. And so there was a tight integration. We chose to let go of that tight integration and tried to replace it with TLS. That's where the shame spiral starts.
Yeah.
And DTLS was, of course, not at the same place as it is now at the time.
No, I just if I can, I mean, I was part of those conversations, and I agree with this direction for a number of reasons, including the ones you're listing, and partly because TLS was a lot less baked. So yes, absolutely, I take some blame here too, no question.
Oh, I'm not trying to pin blame on you and saying what the bleep, but I'm just trying to.
We need to keep it moving.
I'm sorry.
We need to keep it moving.
Sorry.
Look behind you. We need to keep it moving.
The last point, I'll make it very quickly. You asked the question about what's the right architecture. I don't know that there is one. I will point out that what we all care about here is modularity. I don't know that that's necessarily solved by thinking about this as layering or not. I think what we are looking for here is the porous boundary that you're talking about is the API. And we are trying to nail down the right API. And that ties to the fact that we've never used TLS in this particular way in the past. I think it's a worthy exercise because I think having a reliable transport running on top of UDP is something that's not going to end with Quic. So working through this is going to be a valuable process.
Okay, the queue is now cut.
Christian Wiedemann. I listened to your presentation, Eric, and there are a bunch of things that I do agree with. I mean, in particular, we have a problem that we have the same sequence number space in the handshake and in the data exchange, and that's actually one of the root cause of the problems. I am very interested with this midterm evolution that you propose, because one of the things I like about it is that we can do incremental evolutions without losing the implementation momentum that we have. Because yes, there are problems, but there are also about a dozen implementations that are working, so the problems are not unsolvable. So I would rather take an incremental approach in which we plug the good thing from these proposals and keep the momentum. But I have not actually seen the details of this crypto stream proposal.
Nobody has.
And
those are awesome.
So I think that should be the next step, that we actually document that and see how it works.
I think we're doing, yeah. I'm happy to work on that.
Right, Ted Victor was next, and then you.
Can you hear me?
Yes.
All right. So I wanted to make the 2 points, and the main point I wanted to make is that so there are 3 pieces of infrastructure we have here. There is the crypto handshake, there is crypto transport, and then there is the there is the crypto framing, and then there is transport. And effectively, we accepted that we want to duplicate one. And initially, we decided to duplicate crypto framing because it was easier. So fundamentally, I believe this was the right choice because I worked a lot on both framing and on transport, and at some point, I tried implementing both from scratch, and in practice, transport always requires a lot of fine-tuning. But specifically, I want to point out is that the reason I would like us to invest more into that idea of just fixing the problem Quic has with its TLS layering is because I believe we should not duplicate the transport. So I think that the crypto strings and crypto X is one good approach, but fundamentally what you want is you want same transport, but you want two different transport contexts. So I believe we should experiment, we should look into the ideas where we somehow just have two connections for one for crypto and one for the data. And I've proposed that idea on mailing list, and I think, and if you think about it, it makes a lot of sense because we already have different connection IDs for the handshake and for the short header. So if we bifurcate them even further, that would not be that bad, but I've never heard any reaction to that idea on the mailing list. That's my first point. And the second point I wanted to make, which is short, is that...
Victor,
okay.
We are very time constrained, so please make it.
Okay, understood. I will stop at first point then.
Okay, thank you.
Ted Hardy, very quickly, I think Mark Lenzner's principle applies here. You've identified a very clear problem, and now we ask ourselves the question, what's the simplest possible thing that would make it work? I think you came to the conclusion that the simplest possible thing that could make it work is a shift to DTLS. But I think that the proposal that's come out and for which we're still hoping to see a PR is actually simpler for a variety of reasons. For one thing, in part because we don't then have to go and impose new changes on DTLS. All the work can stay here, and I believe it actually, by separating the stream ID frame and the packet type, successfully creates the architecture you want within the control of this working group. Give us a PR. I'm ready for that. I don't want to go DTLS.
So I think, yeah, I think I agree. This is, as I said, it's the simplest thing that can possibly work. I think that it would be really worth exploring whether it can, in fact, possibly work properly. That's worth knowing, right? I'm happy to collaborate with Ian and whoever else wants to collaborate on trying to work through the details. I think I agree that's an important next step.
Patrick.
Okay, so from a code point of view, I want to kind of echo what Brian said a little bit earlier and refine that, where he said, he started out with OO, and now he's like, mega OO. I started out being like, I got Stream 0 figured out. It's there. We heard this on the mailing list. And I actually hacked up this DTLS implementation, which is point number 2, which we'll get to. And I was honestly surprised looking at my own code base with clean eyes, how much of an impact it made. It removed 4 times as much code as it added without question, which was really pretty interesting. So point number 2 is I do have a hacked up version of this that runs DTLS on draft 09, TLS 23, DTLS 23. Right, so coordinate with me probably better next week, and if you're looking to do a little experimenting down that front. But I think the core question, I like the stream separation. It solves a few of our problems. It's certainly cleaner. My favorite thing I like about it is we can actually be clear about what's in a protected state and an unprotected state for what's on stream 0, which is the source of a whole bunch of problems right now. But the core architectural question I've got is, do we want this narrow API or this wide API? So I feel historically almost a little lied to as a developer here. If I go back to my OO days, reading these drafts, I got stream 0, it abstracts away what I need to know about TLS. I got to carry it around. I've done HTTP stacks. I can carry TLS around, get bytes in and out. But it turns out I need to know an extensive amount of information about what is happening exactly when, and that's no longer a byte stream, but almost every interface to TLS I've ever seen in existing API is a byte stream, right? I need events for session tickets and HRRs and blah, blah, blahs. I have to write Martin email that says, what is this byte that's appearing when I don't expect any data to be on that stream, and what protection do I send it under, and how do I hack it, and so on. And the more I've learned actually recently about some particular cases with security and the finished states of the handshake, I am actually ready for someone to make a pretty big security error because of the difficulties in that. So I don't love the way this is currently reconciled. And I think it would be good to talk about that as the focus of kind of how we move forward.
When you say that, you mean what's on screen? You said that.
The width of the TLS API and what we need out of it in order to serve the requirements of Quic.
Subodh Iyengar. When Ecker said I have a better diagram of this, I definitely do. It's like much cooler. Yeah, but way cooler. But architecturally, I think we've been talking about the layering and stuff like that. Architecturally, for me, the most important thing is literally who controls the bytes that are egressed on the wire. As we've seen with the discussions that we've had in the Quic mailing list, like everything from packet number encryption to public flags that we control every single even spin bit or whatever. I don't want to bring that up right now, but it's for a later time. But having control of every single bit that is egressed in the wire is incredibly valuable because we provide additional properties. And so hence transport owning those bits is like the more interesting layering question to me. Who owns this final layer of bits? And so architecturally, I think that the way that it's currently designed is TLS as a service, TLS 1.3 as a service, and Quic doing the one that's egressing the bytes, transport doing the one that's egressing the bytes. I think that's the right way to do things. Although I think that Stream 0 as initially when we came up with Stream 0 and we'll like forget about TLS and it was a completely facetious like decision. And I think it was wrong in hindsight, but I think it's fixable in a way that, and I think there's a spectrum of solutions here to fix it, whereas one of the spectrums is keep Stream 0 and like just go with it. And the other spectrum is literally like have an API between the TLS layer and the transport layer, which is like on client hello, and that is a frame in itself. A client hello is a frame in itself, and it is also a stream frame, which can be terminated. A server hello is a stream frame. So TLS Quic understands every single message that the TLS layer is sending to it. And so in the middle of those two are these crypto streams API. So I think that there is architecturally, this is like the original decision of using TLS service is the right way to go. We just have to find the right middle ground between those two extremes.
Hi, Colin Perkins. I have two somewhat contradictory points. The first is that this approach with the crypto streams and crypto acts looks like it will probably have a very small, conceptually small practical difference to the implementations, but will be a great conceptual simplification to the specification and more conceptually modularize things quite a lot. I think that will be a very good feature going forward. Especially when we look at some of the things being proposed for Quic version 2 and beyond, such as, I hesitate to say the word multicast. It makes it easier conceptually to change the keying and so on, because we've separated it out from the streams in Stream 0. So I think that will potentially be useful going forward. My contradictory point is that we've had a bunch of discussions about multiplexing things like WebRTC, and those already use DTLS. So if we're using DTLS, we simplify some of the problems there.
Andrei Popov, Microsoft. So I'm grateful to Eric for bringing up this discussion, because I think the issue of a complex API between the transport and TLS does exist in Quic, right? So I think it's an existing issue, and if we can come out of this discussion with a better API between the TLS stack and the transport stack, with less coupling perhaps, that would be a great result. The other thing that this discussion highlights, I think, is that a lot of people are not happy with the DTLS transport services or the transport services DTLS provides, in terms of even to the handshake, right? And if we can come out of this again with improved DTLS, with better framing, for example, for DTLS, I think that would be a very positive result as well. So let's keep talking about this.
Kazuho, thank you for presenting this. I theoretically like the DTLS approach, but I do have a concern, and that is about the congestion control. Using DTLS will mean that we cannot easily feed the information that could have been gathered during the handshake phase to the congestion control of Quic. So after the handshake, you'll be transmitting less data than ideal in the normal case, or too much data if there was a loss. I think that is one of the examples that belongs to the nature of having two transports, and there could be others. I'm not sure, but.
Thanks, Kazuho. Yeah, I mean, that's a real concern. I think can somewhat be ameliorated by having back in the same spiral, a wider API that basically gives, gives the calling application information about exactly what happened, because the DTLS does have ACKs, and so they do give it much the same information, though it's slightly less precise. So that would help some, but I agree, there may be some compromise there.
Gabriel Montenegro, Microsoft. So thanks, Ecker, for this presentation. The beginning of this session, the entire session, we saw a very nice diagram about all the latest advances in interoperability. Great chart, everybody interoperating, all that sort of stuff. Replacing, or using the extreme DTLS proposal would basically throw that away or go back several months. I don't think we want to do that. I don't think we need to do that. So I would really caution against seriously considering the full DTLS proposal, also because it may not be echoing what something that Christian said on the list. May not actually be the right architecture if we think about functional decomposition approaches to protocol development. So having said that, I think there's definitely issues with Trim Zero, and proposals and ideas from this document you have produced, for example, like the crypto streams and crypto might be things we want to consider, but definitely not go the full length of the DTLS.
Martin, thank you for defending the end of the line there twice.
Tommy Pauly, Apple. So yeah, thank you for bringing this up. Definitely the Stream Zero architecture issues you've mentioned are very much felt in the implementation. I do have concerns about coupling this with DTLS as DTLS for issues that have been brought up already as relying on the DTLS spec, adjusting. There may be other DTLS use cases that will not want to adjust to this. If we go to the next slide, when the DTLS architecture, I would be curious to see what would happen if we tried to imitate this architecture, because it is very clean for the implementation, but rather than putting DTLS there, just have Quic running the TLS handshake there. And so essentially just don't call it DTLS. Keep it the Quic wire format, because if we want to turn DTLS wire format into Quic's wire format, that's essentially what we're doing anyway. And if we have to come to this, let's think about it in this clean architecture with more of the layering rather than the weird C interlocking thing we had before. Keep them separated out, but let Quic as a transport still run the thing. So let's think of it as a Quic handshake, then gating the rest of the Quic transport on that. And I don't think they would actually end up with that much wire format difference, but it would be an architectural code cleanup.
So I'm not sure if this is what you're talking about. Bart, can you go forward 2 slides? So, sorry, just keep going until you see another diagram. Right, so we floated this when Ian and I were talking, which is basically to essentially cut the details record layer off and replace it with a quick record layer, which would be to cut the details record layer off, so you keep exactly the quick record layer, and then everything that DTLS would have exfiltrated on the wire, you just mark it as a special kind of quick frame, and you say only one can appear in the record, so it looks like 1-to-1.
Or call that your crypto streaming crypto ACK.
Yeah.
Essentially, that's that.
Yeah.
But like it's,
So,
think of it architecturally down below.
Yeah. So anyway, it's another possibility we certainly would explore.
Yeah, and this kind of goes back to my point of like, if we did something like this, we would end up immediately like beating it back into something that looked a little more like Quic, but maybe not as much like Quic does today. But not to say that's a bad thing. I'm just saying, like, because DTLS has streams instead of Quic. So yeah.
All right, Martin Thompson, just to summarize. Patrick talked about the width of the API, and I think that's actually a point of disagreement that we have. For some people, this is a feature, and for a number of us, this is a bug. Victor talked about duplication of various capabilities that we have. The record protection was one that was seen early on as being one that we could safely duplicate. Turns out it's the same code, it's just got different constants in it for the most part. There are problems with the current key schedule that I don't think Eka talked about with respect to forward secrecy and post-compromise security, those sorts of things that DTLS might address. But I don't think that when you duplicate the mechanisms, you necessarily have to duplicate the code. And that was kind of a fallacy in that sort of argument. If you go back to the picture that everyone has sort of been gravitating towards, this starts looking a lot more like like the last diagram, if you think about it from a certain perspective. And The difference there is that the crypto acts look different in the other one to this one. But if you think about this as quick packets containing DTLS records, then you actually end up in a space that's very, very similar to this. You use different encodings for offsets and lengths and things like that inside each one of these things, whether it be a cream frame or not. But it's essentially the same thing. And you can drive these things in very similar ways. The question is who owns the packet numbers or the record sequence numbers, and that's, doesn't really matter. You can pick one or the other. It seems like we have a bit of an attachment issue perhaps to some of the work that we've done, but I'd also remind people that there is such a thing as a sunk cost fallacy, and we should be aware of that. If we can make a change that makes things better for us, then we should do that. I'm very, very sensitive to the amount of time that this is going to take us to do. But I don't think that any of these changes take any more time than any of the others. It's just a matter of addressing all of the architectural concerns or the differences of opinion that we have.
Okay, thanks. Did you guys want to wrap up, or?
I mean, so I feel like the next step is that we definitely have to explore this some more, because there's certainly some interest there, and we should see like we only kind of came with this like 3 days ago. So what I suggest is we can form a coalition of the willing, which I think is going to have to include me and Ian, but other people who want to be involved. I'd ask the chairs to help us keep it small because we can make progress. I don't want to be that one because that seems goofy. And work on this some more. In parallel, I'm going to try to get some people and flesh out some of the other stuff so we have a backup as well. And then I think one much clearer picture by Shista of whether this actually is a viable solution to the Stream Zero problems.
Right. And when we first talked about this, the guidance I gave you was, I don't care if well, I care, but it's not the end of the world if we decide to do this and it takes time to implement it.
Yeah.
But we can't be spinning our wheels deciding.
Right.
From what I've heard here, I'm a lot more comfortable. I don't hear, and please get to the mic and correct me if I'm wrong, I don't hear anybody saying, no, this is crazy talk. Let's, just stay on course. I hear a lot of interest in exploration. I hear pushback at the full DTLS solution. I think you're hearing that too,
Yes.
but there are a lot of potential midpoints that are.
So
that are
I think
interesting.
I'd like to try to come up with at least one and maybe two fully fleshed proposals, and we can try to nail it down hard in Shista.
Do you think you'll have an implementation, even rough?
Oh yeah. I already have a rough implementation. Patrick and I are partway in rough.
Okay.
And we have to do it with the implementation of this, right? That's actually the thing we're further behind on.
The awkward part of all of this is that we gave ourselves a high priority to finish the invariants soon. So this is potentially going to stall that.
I appreciate that.
Okay.
Actually, that was the clarifying question I was going to ask. Was it sounded like your direction was the PR that's the unnumbered slide 9 here was going to be the starting point. And if that's the case, it seems like the quick packet format and all of the applications and streams that don't relate to the handshake can go forward without the presumption that there are going to be any change to DTLS record format or otherwise uptake of DTLS. If that's the case, I think I understand where you're going and it's clear. But if there's going to be a range rather than a point solution, I think it's much harder to know what's going on. So I would suggest rather than multiple, that you and your coalition of the willing come up with a single proposal, and we go from there. Because
Sure, one would hope, yeah.
Gives us a much cleaner way of avoiding the delay that Martin doesn't believe we'll have.
Yeah, so I guess I have some sympathy for that position. Go Martin, you.
Yeah, so I was going to suggest that if we explore this one and something closer to the one that you had in your backup slides, neither of those change the invariance that we're talking about here.
That's an excellent
point. And that's
point.
actually one of the points that I think we could probably relatively quickly come to consensus on, which is the invariants that we have are fine, move on. And if that's the case, then, I mean, if no one's willing to back the full DTLS option, we don't need to worry about the invariant slipping.
Right.
And that's
nice.
That's a plus.
So then the question to the group then is, are we comfortable with commissioning you to explore this with the design team, to report in Stockholm with the constraint that it doesn't break the invariants as we define them?
So I just have a
You wish.
have a question. Is there anybody who is interested in determining which of the two, this one or the slide 9 version of it, who wouldn't be part of the coalition of the willing? Because if the answer is everybody who's going to be interested in the distinction between those two, which are very similar in many ways, is going to be part of the coalition of the willing, let them decide and move on, and don't, you know, it's both a way of implementing that slide 9. This is a subset of slide 9 in my.
Which one is 9?
The 9 is the one with the.
one that was up there.
Detail.
When you made me draw the
Well,
dotted line
so
on.
you're right. The TLS handshake is different. So you're right. But I think that deciding between those two is critical to making real progress.
Well, I guess I would, I mean, I think the reason you're hearing hesitation from me, Ted, is I have two things. First of all, I will admit I'm having trouble giving up on the DTLS record format, but if I have to, fine. But like ignoring that for the moment, like I think it's reasonably likely that we'll have a discussion and we'll be like, these are the pluses and minuses of these things,
Right.
but like we ultimately like there's a lot of people in this working group, but I don't feel comfortable deciding for everything in the working group, like which of two, I mean, not totally dissimilar architectures are right. So maybe we'll come to consensus. That'd be great.
Can we get a show of hands of who is willing or interested in actively participating in this design team?
Oh, God help me.
Yeah, see, this
Okay.
is why I asked.
That's probably too many people.
It's not a bad place to be in, but
Yeah.
Can the chairs take the action item?
Well, if you're interested, please email Lars and me.
Okay.
And we'll take it from there.
Again, I strongly encourage you as chairs, when you put this together, to be very, very clear about how, whether it's doing this or this plus 1 or what, because I think the smaller that number is, and I think 1 is the ideal number, the faster we're going to move.
Okay.
agreed. Personally, so one thing that Martin brought it up at the end, but so if you look at our milestones, which we moved by 6 months, which caused us to get a lot of email from implementers, but they're calling for us to ship RFCs to the ISG in November this year, right? If we are now basically giving ourselves from now until June, it seems unlikely that we're going to make November. If the implementers are okay with that, we're okay with that, right? Let's be clear. This is very likely going to move the milestones, which is, as I said, it's fine if that's what people feel is a good decision, right? If we rather re-architect this bit of Quic, and maybe explain it in a simpler format and make it easier to implement correctly, or trade it off against the slipping timeline, which might slip for other reasons, right? This is not the only thing that's still floating around, but it's a sort of, it's a choice that we need to make, and we need to be aware that this is not a decision that won't have an impact. That isn't to say that sticking with the current design that is arguably harder to implement and understand isn't going to cause implementers to take longer either, right? So this is not clear that this is necessarily going to cause more delays than what we currently have, but any amount of change potentially disrupts implementation activities.
Right.
So we would especially maybe you don't want to go to the microphone, but if implementers are concerned with this change and the impact they have on their roadmaps, we would love to hear that. If you don't want to go to the microphone, send email to Mark and me. If you're an implementer that believes this is the thing you want to do and you're happy with refactoring Stream 0 in this way, we also want to hear that. That would be good to know.
And yeah, I think if for whatever reason the design team isn't able to come to some sort of proposal by Stockholm, we'd need to reevaluate all this again. The default is always to leave it as it is.
So I want to make a comment on that. So I mean, recently we had a connection ID design team, which I think we managed to kick out the door pretty quickly.
Yeah.
And I think that should be a model for like what we're trying to do with this, right?
Absolutely.
I mean, we basically went between an interim and before the next IETF, we had a PR landed that had.
You and I are awesome. Isn't that right?
Did not say that.
So it was also arguably a smaller problem.
Yeah.
It is a smaller problem, but I think if we really try, we can engage and fix things.
Okay.
And I think we need to try to do it in that sort of time frame, not like 3 or 4 months.
All right,
I think
great.
we've done 3 or 4 months, we've failed.
Great. Thank you both very much. We'll take that to the list. Martin?
Can I say something quickly, Mark?
Very quickly.
I just want to thank people for indulging me on this, and thank especially Ian and the rest of the people, and John and the rest of the people who met, like for really being willing to take this seriously. I know I made this point the last minute, and people really dug in. I appreciate it.
Okay, so we have 15 minutes left. We had more time scheduled for this. If we don't get to the end, we can always bump the remainder to Thursday, even though it's a bit awkward.
Yeah. So part of the point of this discussion we were having was so that we could de-risk one of the more important parts of the protocol, which is those parts of the protocol that aren't going to change over time. So if it is the outcome of this discussion, the previous discussion, that we are not going to change the packet layout, which I think we're gravitating towards, there's only one other thing left that we have to change in the invariance draft, and that is this thing. In fact, it's already changed, so I'm just going to go over it very quickly. Next please. So there's a connection ID protocol. Long headers have 2 connection IDs. The first one is for the recipient of that packet. The other one is the sender's expression of what they want the other side to use. So basically one's for routing and one for the routing on the reverse path. They're variable length with a very short range of potential values. And importantly, when you send short headers, there's only the connection ID for the recipient. We use the pair of connection IDs during the handshake in order to essentially negotiate what connection ID is going to be used later on. But ultimately, all you really need is the connection ID that's going to be used to route the packet towards the other one. So next is an overview of the process. So when you send an initial packet as a client, you choose a randomized destination connection ID because you haven't talked to this particular server before. So you don't know what it actually wants. You just pick something at random. And part of the reason we have this initial packet is so that we can specially distinguish these from other packets that maybe get different sorts of routing treatment. Then if you get a version negotiation, those just get echoed, but they get flipped so that the destination connection ID can be used to route the packet correctly to the client. Again, on a retry round, the client uses the randomized one that it used previously, and the server says, hey, here's your connection ID in the destination, but the retry packet contains a connection ID that the server would like the client to use thereafter. Of course, when the server sends a handshake, it can change its mind. So if you think about the case where you have multiple server instances and one of them wants to shed some load statelessly, it picks a connection ID that it uses its current knowledge of the current topology of the cluster and the loads that it has, but that might change over time. And so the server that receives that next handshake, maybe it's not the one that maybe it then can pick a more precisely targeted connection ID for this final SCID2. That's all in the draft. It's pretty straightforward. There's a lot of moving parts in this particular diagram, but that's every single moving part that we have. And you'll notice at the end there, the short headers, only one. Pretty straightforward. Next. So the old invariants looked like this. They're relatively straightforward. You had a bit. And if you had the bit, then you had a connection ID there and a version. And you always had a connection ID. Next slide. The new invariants are a little more complicated. And they're a little bit more complicated because they have 2 connection IDs and their variable length. And we do some interesting bit packing for the lengths in the octet that follows the version. You'll also note that we moved the version. The advantage of that being that now version is in the same place in every one of the long packets. When you have variable length connection IDs ahead of the version, that it'd be jumping around all the time, and that's kind of suboptimal. So we moved it. One of the reasons we had the connection ID up front before was so that it would remain in the same place. But as soon as you put a length in front of it, it was no longer in the same place. So forget that. Next slide, please. The short header is almost identical to how it used to be, except for one thing. We removed the bit that said whether the connection ID was there or not. Because one of the things we can do with this particular design is say that the connection ID is 0 length. And voila, now you have no connection ID. You don't need to have a bit. You just, as a server, for instance, when you say to the client, use this particular connection ID, if you don't want them to have a connection ID, you tell them it's 0 length. And that works out pretty nicely. Next. I think we're almost there. Yes. So this is really the main cost of this design. So for clients that rely, well, in general, endpoints that rely on having a connection ID for routing the packet toward them find themselves in a bit of a bind, because the peer that receives a packet can generate a stateless reset based on the design that we have, but it won't be able to generate the correct connection ID to put on that packet such that it will get back to the client that sent it. It doesn't know where it came from in the vast cluster on the other side that is potentially being used by for instance, the client. So what we do now is we advise simply setting a random connection ID and acknowledge that this might have some problems. It might be that a stateless reset is now recognizable as a stateless reset because suddenly this particular flow has a new connection ID appearing on it. That's not so much of a problem if people use new connection ID with some frequency, but it's still a potential exposure. But probably the big one is that the stateless reset might not arrive at the right client. And the suggestion here is that, well, stateless reset is only an optimization. If you're forced to use connection IDs for routing on your end, then don't expect to be receiving stateless resets and just deal with it. Colin.
Sorry, I had a comment on the previous, so I can wait till the end.
All right, I think we're almost at the end. Maybe we'll go to the end and we'll see. Okay, so the PR, which has been merged, actually all the PRs have been merged, create the connection IDs, move the version negotiation, version field. Version negotiation changes as well, but it's just using the same long header format, so not really a fundamental change. It's still just a long packet with a version number of 0. There's a little bit of a gotcha in terms of return routability checks when you do a retry and the server requires a 0 length connection ID, but that's not a big problem because you had validation on a previous round trip. So the text covers all of this. I don't think there's been anyone push back on any of these changes. The question that we have is this good enough for now? And Colin's going to tell me that he wants to do some demux stuff, most likely. And we can talk about that for some.
Hi, Colin Perkins. So what I was going to say was for the short header packets, the invariants don't guarantee that you can demux stun. If we are ever going to run peer-to-peer, we either need to be able to demux stun or reinvent it within Quic.
Correct. The invariants do not guarantee that. There may be properties of individual versions that we can use to guarantee that that particular version will demux with stun, but the invariants don't provide that guarantee. Correct.
I think if we can, that would be a useful guarantee to provide.
Previously, we had sort of been operating under the assumption that it was acceptable for folks who wanted to do some of the real-time applications that we're talking about to know what versions were being negotiated.
It's not so much for the real-time applications. It's if we ever want to run Quic peer-to-peer, we need NAT traversal, which means we either need stun or we need to reinvent it.
But the assumption there was that there was some form of signaling in those applications and that you could use that signaling to negotiate versions that were compatible with the sort of NAT traversal that you were employing in those applications.
Yes, and we can do it. We can make it Quic version specific if we want. But
yes,
it would be cleaner in some ways if we could make it.
Understood. Yes. Though I don't think we go for clean.
We're going to close the line on this after Roy, and if there's more need to discuss it, we're going to do the discussion on Thursday because we have 2 lightning talks that are previewing talks that are given elsewhere later in the week that we want to get to. But go on.
So, I mean, while as a technical theoretical matter, this does not guarantee the ability to demux with stun. As a practical matter, stun has the fingerprint, and therefore you can demux with stun. So it doesn't require you to know which version you have. So I'm not actually worried about that. I mean, I guess there's a 1 in 1/128th chance that like you're gonna have a problem, but it seems like pretty low.
It's much worse than that because stun has fingerprints and integrity checks and all sorts of other.
1 in 2 to the 2d6 was like. Of course, if we do colon stun, that'll be different. But the next thing I wanted to say, and I just want to double check with you, is we discussed on the mailing list adopting the version negotiation scheme that I suggested for DTLS in Quic, where the Quic version is negotiated in the primary Quic version is negotiated by offer answer rather than by assert and reject. I don't think that breaks the invariance, but we need to make sure it doesn't.
As far as I'm aware, it doesn't, but we can go through the details. What that changes is that the version field that you see in the clear determines the packet obfuscation technique and the means by which you do version negotiation inside.
Yeah, I mean, so I think that the failure case, if there was one, would be that the outgoing packet came with Quic version X, but then when you internally negotiate it, you might return Quic version Y, because we haven't decided which rule that is. And so that's something which we might want to be careful about. I mean, I guess we could just solve the problem by saying the invariant does not guarantee the packets in both directions of the same version, and then the problem will go away. And maybe we want to do it at all. That's a possibility.
I think we can do that.
Okay.
Yeah, I think we can do that. I'll let people think about that for a moment because that's tricky. But
that's why I want to
yeah, no, that's good. That's a good addition.
Troy Fielding. Do we have working group consensus that the version is 32 bits?
Would you like to challenge that right now? Because it was assumed, I think. No one said anything about it. No one suggested otherwise. I know that there's a bunch of people who really want 32, but you know.
Okay.
Which color would you like to paint that bike shed? Because I did put that warning on the front of the presentation.
Editorially, the diagrams would look better for 16 bits.
Great feedback, Brian. Great feedback.
16 is enough for anyone.
Okay.
It has been for TLS as a practical point, but I think there's a number of people who want far more room to move. I don't know. I don't know what they're going to do with them, but
So
yeah.
They should land this way.
yeah, you've already landed these, right?
This is all landed. I
Right.
mean, as far as I'm concerned, as long as we don't decide to rock the boat too much with the changes to the stream zero stuff.
Sure.
This is done.
So the intent is to, as I understand it, is to do a working group last call on this.
Yes.
Go through that process, conclude that process, and then park it until we ship the rest of the documents.
I think that'd be a good
with the
strategy.
semantic that if we can change it later on, but it's a fairly high bar to do so. We're intending not to break our word with this.
Yeah.
Is that what where we're at?
Yep.
And can we start
let's
the
do that.
working group last call now? Sorry? Because we can't predict the future.
And because until someone, okay, so I'm going to repeat Jana's question. Jana would like to know why we're parking it rather than publishing it. And so Mark suggests we don't know what the future is. Obviously, anything we do with this document after publication, whenever that publication date is still subject to the same sort of we don't know, we can't predict the future, and maybe we made the wrong decisions and whatnot. But I think the key point here is that while the patient is on the table, things might go in and out that cause us to regret our decision to publish an invariance document.
Right.
And there is no version of Quic that depends on those invariants until we publish version 1.
Exactly.
So there's not really that much of an advantage. But
Also,
as long as
if-
we agree to the invariants here and have some sort of commitment to them, that's really what you're looking for. You're looking for people to nail these down such that they don't move around.
Right.
And that's what's been concerning people with, like Ian in particular, who's trying to, move a good chunk of the internet traffic onto this new invariant scheme is finding particularly distressing. So we need to give Ian some certainty, for instance.
Also, if we publish a series of documents called invariants that change, people may not believe us after a while. Yeah. Okay. So, last question? Do you think we're ready for working group last call?
I would like to fix Ekka's comment, which I think is a very minor one. And that'll be up in a pull request in, I imagine, minutes.
Do that,
We can
and
do that.
we'll start the process. I think.
Yeah.
Okay.
Let's do that next week, or plan to do that next week.
Sure,
Yep.
sure.
Right. The two guys with lightning talks, come on up.
2 minutes max.
There are 2.5 that on the agenda, so yeah, Jan is first. He's the measurement.
This one?
No, the other one. The one in the wild, 2 down. That one. Start talking already.
Okay. Hi, I'm Jan. So If you're interested in how Quic is deployed in the wild already, be sure to be here tomorrow in the same room at the MapRG research group, and you will hear how you can enumerate Quic hosts in IPv4, how many websites there are that already are deployed on Quic-capable infrastructure, and how many you can actually use. Furthermore, we monitored actual internet traffic in a major European tier 1, in a mobile network, and at an IXP, as well as in an open trace, and we'll show how much Quic there is. If you don't have time, you can read our paper, you can get on that URL, and yeah, see the rest. Thank you.
Thank you. Right. The other one was this one?
Yeah,
that one, yeah.
Start talking.
Hello, we have a draft in TSVWG, which is packetization layer path-empty discovery for datagram transports. We're trying to lay out standard algorithms for doing datagram path-empty discovery. And we set this up for SCTP, SCP over DTLS, UDP and tunnels. We'd love to have Quic involved. Next slide. For this, we require that path layers can signal their MSS, send probe packets, process pack-to-big messages, and have some way to do reception feedback so they can work around ICMP black holes. And with these, none of this should expose anything to the path, so it's friendly with Quic. Next slide. Yeah, and this, we just have some quick questions for you. We would love to have conversations about people who have data on path MTUs. And we would like to speak to anybody within Quic working group who wants to work with us on datagram path layer, path MTU discovery. And if you want to know more about this, we have a presentation on Thursday afternoon in TSVWG. Thank you.
Lovely. Thank you.
Thank you.
So
that was on time.
Fantastic. So we'll see everyone on Thursday. We'll move the ECN discussion to Thursday.
Yes.
And we'll also discuss the spin bit.
Yeah. Come on up and sign the blue sheet if you haven't signed it yet.